Thank you very much for attending the session. What we are talking about is the investigation of the confined and confined aquifer in the Southeast Victoria border sharing zone, and whether we manage it as one single resource or two separate aquifers. The groundwater resources are managed between the two states, Victoria and South Australia, by the border sharing agreement, which established the designated area or zone, which is this one. It's a 40-kilometer strip centered on the border between the two states and extend through the whole state. The area of interest is zone 2A, 2B, 3A, 3B. And the project was funded under the National Water Commission Raising National Water Standards Program, Australia government. It was a joint project between Department DSE from Victoria and donor from South Australia. The technical work, South Australia, the department did it, and for Victorian DSE, SKM, or now Jacob was involved in carrying on the technical work. So this is an exaggeration site of, this is just a map of the sites of investigation, and there were a few studies done previously, and there are over there. And these studies were looking into the hydraulic interconnection or the dynamic of the resource itself, and especially the confined and confined. And Brown et al. Is also, they looked into leakage from the unconfined to the confined aquifer. And the conclusion or the indication was there is a leakage happening, and there was speculation that this leakage is high from the management point of view. So the question was, how are we going to manage this one? Can you manage it if it is too high? Shall we manage it as a one resource or two resources? Especially if you're looking into this area. This is in Victoria. This is an unconfined section of the aquifer, and it was very transmissive and almost now exhausted because it's a very shallow unconfined aquifer. So if you prove this is a very highly confined, then they were thinking they might go into the confined without any issues. And as you see, there is a lot of linear sign, which could be indication of faults or fractures. So the area is heavily fractured and faulted. Previous work done by Brown was concentrated on site SA-4 and SA-3. So for the research, we expanded a little bit further. We took another two sites in South Australia, which is SA-1 and SA-2, and we had new 4 sites in Victoria. The reason we had them in this area because the unconfined is very thin and the confined aquifer is shallow, and some places the confining layer is very thin or missing as well, or sometimes very gritty. So there is a potential for interconnection between the two aquifers happening. So for then hydrogeologists are bound by the 10 Commandments. And if we look at the number 7, thou shalt not place geochemical interpretation above hydraulic interpretation. So if you go to geochemical data, by interpreting by themselves, they might give you false indication or wrong indication. You need to understand the hydraulics of the system itself so you can tie both of them. So methodology, we use the seismic data to trace the fault lines. Surface geophysics, we use nano-TM, try again to identify where is the area there is a break or change in the aquitard or change in the formations. And we did drilling about 39 wells. We took some coring from the aquitard for permeability test using triaxial test, and also pumping test, 3 days pumping for production wells, and monitoring the different units in the unconfined and also monitoring the confined water. It was 3-day pumping and 24 hours recovery. Water samples also collected from different units and from the confined and confined before and after the pumping test, and included general chemistry, environmental isotopes, and tracers. So this is some examples of the geophysics, surface geophysics, nano-TM. And the top one is from SA-1. You can see there is a conductive layer which represents the confining aquifer and dipping this way. And for interest, there is this structure. It could be related to a fault, or also this area also corresponds to crossing the road and some phases. So the data should be treated with consideration. The second one from SA2 and, sorry, from SA2 site, which is again, this high conductive layer represents the top of the confined. And as you said, it's very flat, continuous, but there is a break here, which could indicate a normal fault happening in this area. SA-VIC3, we can see again the conductive layer, which represents the top of confined, flat, then nothing here, which means there is a potential or actually good connectivity between the two aquifers, because the aquitard is missing in this area. And again, this is VIC4. There is an indication of a high conductive layer here, could be a perch or could be high content of clay. And then there is this structure here, may interpret it as a fault or a break in the, or change in the lithology. These are the results from drilling, and you can see it's not homogeneous. There is a variation, big variation in terms of the units and also thickness of the aquitard. This is the aquitard, and this VIC4, actually we went through 2 units of confining sands. When you look into hydraulic head, all of the wells, all the site, except VIC3, the head in the unconfined is higher than the confined, which means potential for water moving from top to bottom. When we look into VIC3, it's almost the same, which means there's a good connection between the two aquifers. This is the results from triaxial test, and also that's the vertical hydraulic conductivity for the confining layer, and from pumping test. And you can see for Victoria, we couldn't obtain like a core because it was just silty and couldn't hold. But we had a value from pumping test which actually shows a high conductivity, 2.7 minus 1 to 1.3 meter per day, and also SA2, which again 4.82. So you may see that the figures from triaxial are a bit higher. The reason is because triaxial, it's a biased section. We just pick up the most representative section. So while pumping test, we know always it goes further out, and then you can get representation of the aquifer respond to your pumping. When we look to the chemistry again, we use CFC, PMC, which is percent molar carbon and other factors. Generally, when you look into the blue dots are the samples before pumping, and the red dots after pumping. So it doesn't show there is a physical mixing happened during the pumping. Almost the same, but there is some differences, but most of the confining layer actually shows like some sort of, especially if we look into VIC3, it shows there is percentage of modern water into the confined aquifer. And the same thing for the rest of the wells. But in the VIC3 is a bit higher, because as I said, there was no aquitard in this area, so there is a good connection between them. From South Australia, the same, there wasn't any indication that physical mixing happened during the pumping test. But when you look into VIC, SA-2, again, unfortunately, the unconfined was almost dry. We couldn't get enough water to test it, so the water samples we collected from both the confined production well and also the confined observation well. And both of them, they show a high, about 78 to 85% PMC, modern carbon, which means there is a good leakage happening in this area. So as conclusion and recommendation, because the aquifer is so inhomogeneous, and that shows from the geophysics, shows from geology, which cutting of the samples we contact, and also varies in terms of thickness and in terms of content. At least this work shows there are two sites which show a good connection, or effectively no aquifer, so there's a good connection between the two systems. Hydrochemical tracers, as I said before, pumping and after pumping didn't indicate any physical mixing happening. Either the time wasn't enough, or the mixing could happening through not diffuse or through fracture or say fault lines, which means taking a preferential flow paths, and we couldn't pick it up here. Carbon-14 activities actually supports the previous work and also supports the understanding that there is modern water going into the confined aquifer. And results indicate that there is a moderate to good hydroconnectivity between both of them. And the recommendation is to treat them as two separate aquifers, because there's not enough evidence to support this connection is high. And also this area should be considered for future management. The reason is it's a recharge area for the confined, and currently most of the area is covered by plantation. Thank you very much.